Welcome to this GCSE Physics presentation on forces. In this video, we'll cover every essential topic from scalar and vector quantities to changes in momentum. Big question: why do objects speed up, slow down, or change direction? Exam promise: by the end of this topic, you'll confidently draw force diagrams and calculate key quantities for AQA GCSE Physics. A force is a push or a pull upon an object resulting from the object's interaction with another object. It is a vector quantity measured in newtons, n, that can cause an object to change its speed, direction, or shape. Scalars have only size, or magnitude. Vectors, on the other hand, include both magnitude and direction. Force, for example, is a vector quantity. Contact forces occur when objects physically touch, like friction or tension. Non-contact forces act at a distance, like gravity or magnetism. Gravity, resultant forces, and work done. Gravity pulls objects toward Earth with a strength of 9.8 newtons per kilogram. Weight is calculated by multiplying mass by gravitational field strength. A resultant force is a single force that has the same effect as all the forces acting on an object combined. If forces are unbalanced, the object will accelerate. Work is done when a force moves an object. This transfers energy. It's measured in joules and calculated using the formula, work equals force times distance. Deformation, rotation, and pressure. Elastic materials stretch when force is applied and return to shape when it's removed. Hooke's law tells us force equals the spring constant times the extension. Moments are the turning effects of a force. Levers and gears are simple machines that help us apply less force or change motion effectively. In fluids, pressure depends on depth and density. Deeper in a liquid, the pressure is higher because there's more fluid above pushing down. Atmospheric pressure is the force from air molecules. It decreases with height because there are fewer molecules the higher you go. Forces and motion graphs. Distance is the total path traveled, while displacement is the straight line vector from start to end point. Speed is how fast something moves, velocity includes direction. For example, 13 meters per second east is a velocity, while 13 meters per second alone is just speed. A distance time graph shows how far an object moves over time. The steeper the line, the faster the speed. Curved lines mean acceleration or deceleration. Acceleration tells us how quickly velocity changes. It's measured in meters per second squared. Newton's laws, braking, and revision. Newton's first law states that an object remains in motion or at rest unless a resultant force acts upon it. Newton's second law links force, mass, and acceleration. A greater force or a smaller mass means a greater acceleration. When you push on something, it pushes back with equal force in the opposite direction. That's Newton's third law. The total stopping distance is the sum of the thinking and braking distances. It increases with speed and poor road or car conditions. Reaction time is how long it takes to respond to a stimulus. It can be slowed by fatigue, alcohol, or using a phone. Heavy, fast-moving vehicles take longer to stop. Worn brakes or wet roads increase braking distance. Momentum depends on an object's mass and velocity. A larger or faster object has more momentum. In collisions, the total momentum stays the same, provided no external forces act. This is the principle of conservation of momentum. Changing momentum quickly requires a large force. Safety features work by increasing the time taken, reducing the force on passengers. To sum up, we've looked at all the key topics on forces, from motion and Newton's laws to safety in vehicles using momentum and stopping distances.